You have an image, and you want to know what's in that image. One of the most popular ways to do this with machine learning is using a residual network, or a ResNet. A ResNet is a deep neural network that takes an image and passes it through all the neural network layers to produce a classification. And how deep is it, you may wonder? Well, pretty deep. As we can see, the image passes through each of these layers where features are extracted layer by layer until at the very end, we get a classification. In this case, an Old English sheepdog. And to train these networks, we use something called backpropagation, in which we compare the network's generated output with the true output, and then we propagate that back to be able to tune our parameters to find the best frequency, the best setting for our network. So to do backpropagation, we need to start at the very end where we can compare the predicted and the real values. And then we need to propagate that all the way back. For really large networks, this can introduce a problem. The problem is often called vanishing or exploding gradients. It's like standing on the top of a distant hill, screaming up the top of your lungs. But because the air dampens your signal the further it travels, what's left at the end is pretty much nothing. That's where the residual in ResNet comes in. Instead of just screaming at the top of our lungs, we introduce something called residual connections, which act as shortcuts to get our signal from the bottom to the top. Formally, we use something called a residual block, where the input x both passes through weight layers that needs to go through our tweaking and parameters, but it can also take a shortcut. And at the end, we just add them back together. So if we call that output h of x, we know it's the combination of the learn mapping with just the input, or the identity. And solving for the learn mapping, we can see it's just the difference between the output and the input. And this is what's called a residual. So instead of learning the full transformation, we're just learning the difference. And this leads to faster optimization, improved features being propagated back, which allow for larger networks, which have proven to have better performance than smaller networks. Okay, that's great, but how do we use this? We can go on the Hugging Face website and download the Microsoft ResNet 50, which means that this ResNet has 50 of these residual blocks. Next, we find a data set of images that we want to use. And finally, we import the model using these lines right here, import the image that we want to use, and then we can use the model to get its predictions and get the label. And note that the ResNet is trained on the ImageNet classes and ImageNet data, which means that from the get-go, it can only produce these 1,000 predetermined classes. So if you want to change which classes it can produce, you need to do something called fine-tuning. But that's a topic for another video. So there you have it. That's a ResNet, and why it has become such a popular deep neural network. Thank you for watching. Bye.